and they can sneak up on you. Now, we're not on their menu, but if they're really hungry, they'll eat anything. So they can be dangerous. Getting ready for processing. The 2 ships are out there on the bag. Keep on going and keep looking off to your right, off to your right, off to your right.
A model of a V2 rocket here. This particular version of the V2 is called a bumper, and it's got what's called a WAC Corporal rocket on top, so it's a multi-stage rocket, and this was the first ever multi-stage rocket ever successfully launched. As a matter of fact, the very first launch from Cape Canaveral was Bumper 8, launched in 1950 at Complex 3. It had equipment rack, which was purely used for test purposes, and it's the only Gemini launched twice into space. It was brought back, refurnished, launched again. And around the back side, you get a good view of the ablated heat shield. Unlike the shuttle, which uses tiles, how thick that ablated is. I would have to guess the carbon, there's probably asbestos in there. That's back in the
Doors.
A-pad, not a D-pad, so you've got a display set up. But for the most part, this blockhouse looks the same as it did in 1958, the same light fixtures and ceiling tiles, and most of this equipment is actual from this blockhouse. There's been a few test racks brought in that weren't part of the blockhouse. They're just brought in to show the technology of the era. This blockhouse is about 400 feet from the launch pad, because back then analog technology was used, and the nature of that technology was such that if you ran wires much longer than that, you lose some of the signal strength. So you had to be close, but because they're close, you had to have a substantial structure to put the people in. So the walls are 2 feet thick, the ceiling is about 5 feet thick on the edge, and upwards of 8 feet thick in the center. This glass is 1 foot thick. It's composed of 3 sections, each with 15 panes. And when we go around the corner, you'll be able to see a sample of what is 1/3 of the thickness of this window.
Wow, that's thick glass.
Okay, let's go around the corner. You'll notice there's a large scale. When you watch on television the shuttle trip sitting on the pad, whether here's the steam coming out, that's gaseous hydrogen or oxygen venting, they lose some of the propellant because it boils off, so they have to continuously fill the tanks to have enough propellant to make it work. The same was true back in the 50s. If the liquid oxygen would boil off, they'd have to keep topping it off. But instead of having float switches back then, they had a scale. That rocket is sitting on a scale, and this was the readout. And once they were satisfied they had enough propellant on board, they were ready to launch. This is an Atlas guidance computer, and the whole room is one computer. And this part here is just the memory. And I've been told that it has a whopping 5K of capacity.
5K memory.
That was probably pretty good stuff.
That's what makes you laugh. Huge computers.
Before we launched the astronauts into space, with a panel with some colored lights, and the chimpanzees were trained on the ground to perform a simple task based upon the lights they saw in the sequence. And then they replicated the task of the satellite. This is just an upper stage motor here. And the batteries kept working for a month or two, and then it died, but it did its job. But it stayed on orbit until, I believe, 1970.
Here, come get your picture taken.
Come right on in.
Ah, there you are. Come in, come in. Welcome to Blockhouse 5-6. Between 1958 and 1961, the entire world was watching what went on in this room. It's a place that's full of memories for me, even though it's been locked up for more than 30 years. Now, it's been designated by Congress as a National Historic Site. It'll be preserved for future generations to see and to share. But it isn't history for me. It's memories of making history. And every one of us who worked in this little building knew it while we were doing it. What we didn't know was whether or not it would be successful. I was here from the beginning, working as a propulsion engineer, and that goes back to the summer of 1957. That's when the world's first man-made object to reach space and then to be recovered was launched right from this site. It was a different world when we gave Alan Shepard his history-making ride to the edge of space in 1961. In the first place, we hadn't a clue what would actually happen to the human body in a weightless environment. We knew Yuri Gagarin went up for the Russians just a month earlier. But the Russians weren't talking, so for us, this was all still theory. And on top of that, rocket science was still just a baby. Test rockets were still exploding with some frequency, so there were no guarantees that something wouldn't go wrong. I was in here with about 100 people that day. Von Braun came down from the Redstone facility for the launch. He was standing behind the firing console, as you can see from the photograph. He's the one wearing the sunglasses. Now, we needed 70 or so technicians just to watch all of these panels, and another 10 people out on the pad to take the Redstone's pulse right up to the minute before launch. Then the guys would scramble into the blockhouse and slam the door. Now, if you look out the window, you can see the launch pad is just 300 feet away. The safe distance for shuttle launches these days is 3 miles, which gives you some idea of how small the Redstone is by comparison. And you wouldn't believe how smoky it was in here. I mean, just about everybody smoked. Nobody thought it was dangerous back then. If you look, you'll see in the console there's these little pull-out ashtrays. I mean, that's how common it was. Now, we left one of the state-of-the-art at the time, but we were really making it up as we went along. It was a whole new technology growing up before our eyes. But by today's standards, everything we did was really primitive. Our gantry was bolted together from an oil drilling rig. And we installed a scale from a commercial truck weighing station under the launch pad because we had to know the weight of the rocket at liftoff time. Now, in that room behind us, the readout showed up on that big dial. And if you could look inside all this electronic gear, you'd see thousands of vacuum tubes and fat wires and hand-soldered circuit boards. Within a few years, the space program would push technology so hard that we could miniaturize all the gear in this blockhouse and fit it under the dashboard of a pickup truck. Oh, here in the middle of the room is the launch director's console where Bob Auger sat. Everybody reported to him at launch time. Bob would run down the list of vital systems: engines, guidance, rescue, medical, weather, communications. And we'd all report in with our go or no-go. With Shepard sitting up there in Freedom 7, we were sweating so bad our socks were squishing. It had been tough enough sending up little test monkeys, but this, I mean, we had a man we all really liked perched on top of a trainload of explosives. And we were going to send him up to a weightless place where his eyes might pop out of his head or his heart might stop. All that plus 1,000 other things we could only guess might go wrong. We were all looking at each other. I mean, who could you get to push the button that might turn Alan Shepard into a Roman candle? Well, it turned out it was Shepard himself. He'd been sitting up there for hours while we checked and rechecked everything, from the launch director's shoe size to the number of peanuts left in a snack ball. Maybe he thought that getting vaporized was preferable to waiting any longer. More than likely, it was his unimaginable courage. He pushed all of us into that first shot when he said, "Come on, guys, let's light this candle." By the time we got to the countdown, the tension in this room was so thick you couldn't cut it with a cheese slicer. I mean, every second felt like an hour. And even after that 3, 2, 1 countdown, a lot had to happen in here. Once the fire button was pushed, it took about 5 seconds for the fuel tanks to pressurize. Then the rocket lit up, and we had to wait and watch for another 20 seconds while this thing built up enough thrust to lift us off. On top of that, we had this little guy who came down with the other scientists from Redstone. He was standing at the window over there with his hand in the air. His job was to watch the color of the fire shooting out of the rocket. If the color was right, he'd give us a thumbs up that told us it was okay to release the Redstone. Thumbs down, and we'd have to pull the plug. Lucky for us, it was thumbs up. And the rest is history. By the time the Mercury and Gemini and Apollo program were completed, there were over 450,000 of us working on the science and the hardware of our first steps into the universe. These people are the real heroes of the future we're beginning to live today, though most of us will never know their names. But trust me, not one of us will ever forget the names of some of them: Shepard, Grissom, Glenn, Armstrong, Aldrin. And it all started here, right here where you stand at this very moment. I gotta tell you, it gives me goosebumps.
He doesn't say goodbye, he just goes away. Back into his resistor or wherever he's hiding. Take your pictures, hop back on the bus. In the portfolio that I gave you of this launch, by the way, nice colored picture.
See a rocket out here, Tyler?
It also has our escape vehicle right beside it, a cherry picker. If anything happened, that's the way we were going to get them out. Other than the red tower that's sitting on top of the capsule, would pull it out, deposit it out in the Atlantic Ocean. Hopefully.
People.
Wait till we show you the blockhouse that had 580 in it. I imagine it all boiled down to one button somewhere along the line because there weren't computers like there are now.
Shut up. waiting to see how long it would take you to do that.
Geminis, the big Titan II rockets. Keep that in mind because I'm going to have you recall that to memory. We're going to show you where that actually came from. When we get full into our restoration, all things being equal, we'll show you where it's going to go back. Now as we come up here into our rocket garden, you'll see something that looks like an oil derrick. Well, that's what it is. It's an Oklahoma oil rig converted to rocket launch use by a man by the name of Gantry. And ever since we did those modifications, that name stuck. Now everything we do is a Gantry. But it got us to where we needed to be in a big hurry, addressing the needs of the vehicle while it was out on the launch pad. Give us access. It would be rolled back just before launch. We'd launch from the near vicinity. Look to this side on the ground of the gantry. 3 capsules. The one on the left is a Mercury. The one in the middle is an Apollo. The one to the right of that is a Gemini. Mercury, 1-man. Gemini, 2-man. Apollo, 3-man. These are what are called boilerplate. They would be used for mechanical tests like drop tests, impact tests, weight and balance, and things like that. Notice the Polaris missiles here. We launched those, and I'll show you from where, before they were deployed on submarines. The one green one on its side out there is a Pershing II. They were deployed in Turkey. Made some negotiations with the Soviet Union. We took them out. They took some missiles out of Cuba, didn't they? The one silver one lying on its side is an Atlas. Quite like the configuration that we flew John Glenn in the first orbital pad. The rocket standing up out there is a Thor Able. On top of that is one of the many, many capsules that we launched for various reasons. The one lying down is a Thor Delta. Later became the Delta rockets that we launch nowadays. The vehicle with the wheels, that would be kind of tough to launch, wouldn't it? But that was its purpose. We would launch it out into the ocean to recover the capsule if we had to jettison the capsule prematurely. That red tower would pull the capsule off and deposit it out in the Atlantic. We would take this vehicle out there to get it. I don't know whether I would stay in the capsule or get on the vehicle, but they both look risky to me. Lying down here on the side is a Titan I, intercontinental ballistic missile of the early vintage, capable of deploying thermonuclear warheads. Thank God we never had to do that in anger. As we come past it on the left, there are vehicle with the red wings. There's a Bull Goose, radio controlled. We'll show you where we launched those from. The same as the vehicle coming up in front of us, a Mace. Essentially a winged bomb, controlled from the ground. Either launched from a fixed platform or from the mobile launch platform that you see it on right now. Again, as we go around the corner here, off to your left inside that concrete bunker are a couple of upper stages that we call Agena. Agena A and B over there. They either had engines or didn't have engines, depending on what the mission was. The Agena D we used as a target vehicle for the Gemini when we were practicing rendezvous and docking. They would have been launched on top of our Atlas rockets. Lying down straight ahead of us and off to the left a little bit, one of the Minutemen, early Minutemen. We're going to show you where we tested and launched those, including some from silos, because the Minutemen were nestled in silos when they were finally deployed for national defense. The red vehicle out there on your left is a Snark. That's the only one out here that had a ride. That one flew. Brought it back on our skid strip on skids. That one made it. We have a lot of them that didn't. So that one got an honorarium. The Minuteman will be launched from the surface, and also there's some silos way out there to your left, 12 feet in diameter, 80 feet deep, where we had to do silo launches to prove their worthiness. This blockhouse off to your left right here had a set of mirrors rather than periscopes. Mirrors inside allow the engineers to see out at the building that's straight ahead of us. This is where we launched the Navajo. The Navajo was quite like the Mace, a winged bomb. It was never very successful. Only about 25% of them did what we wanted them to do, but this is how you find out. The building right ahead of us, slightly to your right, is where we would launch them from. We bring them out here like an airplane. We put them on their launch platform. It would be raised up so that the exhaust plume would go down through a special concrete channel and out the back. You'll see that when we get a little further ahead here. Some of them would sit there and fizzle. Some would sit there and dismember themselves. Others would launch. They might go 100 feet. They might go 100 miles. Not good enough. There is another place of significance while we're out here. Look off to your left, way in the distance. You'll see two, well actually you're going to see a dome from one of our silos out there. The other silo is right next to it. Underneath that white dome is where the remains of Challenger is. After the Challenger accident, we recovered about 85% of the debris. We brought it back in. We did all the investigation and scientific analysis that we could to define what was wrong and fix that problem. After that, all of that hardware was gathered together and put down inside that silo. The lid weighs 27 tons. It's also welded in place. You're not going to have anybody trafficking in parts to the Challenger. It wouldn't be respectful. It's not acceptable. Tree to the right of the two, you see the green cylinder in there? With the white rocket strapped to the bottom. That's a Delta II. That Delta II is going to launch the package to Mars on the 7th of next month. It's the 2001 Mars Odyssey capsule. It's going to take 5 months to make the trip, and it will go into Martian orbit. We won't do another Mars launch until June of 2003, when we'll launch two of them 20 days apart. The first one will reach Mars that December, the second one the following January, and they will be polar orbiting, and they'll send probes to the surface. Now I'm telling you what the schedule says. I'm not saying what's going to be funded. We'll see what happens. And you see it right now. It's been sitting on this site for over 100 years. The hangar that's right next to it, Hangar C, a lot of history there. It's where Wernher von Braun had his first offices. When we would be launching his rockets, he would come running down the steps across the grass, climb up into the lighthouse and watch the action. Until NASA found out he was doing that. He said, no, you're going to get in the blockhouse with everybody else. And we're going to go slowly. If you want to take pictures, is there anything behind you, Barry? Okay, what we're going to do is stop right in the middle of the street while you take your picture so the bus will be still. Let me tell you a little more about it. The restoration process that's going to be going on with this thing will include 2 of the 5 original houses that were used by Captain Burnham, who was the first of the lighthouse keepers in the 1840s. His family managed that lighthouse for many, many, many years. And then finally, when it was moved here, we even brought the brick house that would have stored the fuel. Originally whale oil, then the kerosene, and now it's electrified. Coast Guard has jurisdiction. It's on Air Force property. So we have a lot of red tape to cut before we can go through the restoration. The money is already available to do that. The plans are to also rebuild 2 of the 5 cottages. So it'll look quite like it did 160 years ago. That's even older than me. By a little bit.
I just remembered a cute little story.
You remember back then?
Yeah, I just remembered back then. Remember the redstone? The black and white redstone? Newspaper people would come out here and say, where do we shoot at? And they said, look for the black and white thing.
We used to launch these right off of that porch. We would have airplanes that would come by, chase planes, that would control them out over the ocean. Every once in a while, we'd be a little late in our launch. Chase plane would go over, and we'd send a mace up right behind it. Where is my target? Look in your rearview mirror. You would hear a whole string of expletives, and then the pilot would take evasive action because this thing's about to fly up his tutu. That went on, not always, but enough to say we still better be out in the wilderness when we do this stuff. This little area that you see off to your right now, as we move up a little bit, has an asphalt surface. Now you remember that some of these things were on mobile launchers. Well, we had to test those too, and this is where we would do it. Bring them right into this asphalt area and launch from there. Same scenario. They'd either be controlled from the ground or controlled by a chase plane. They got a little weary of us after a while. I want to see it. They're out here. I would say the other one is probably going to be a military or Department of Defense payload, and they just won't tell us where it is. Kind of hard to hide something that big. What did he do besides flying the Gemini? Nobody knows that Neil Armstrong was the first man to put a boot mark on the moon? Of course we do. You're just bashful. You don't want to say anything. Look at GT6 and 7. Out of order. Well, we were going to do a rendezvous up there with an Agena, and then Agena failed to launch. So what we did was launch another Gemini. These two Gemini vehicles got within 1 foot of each other. This blockhouse has walls 21 feet thick. Ceiling is the same, a double concrete ceiling with sand in between. It'll hold 338 people, comfortably like sardines.
I remembered another story.
Go right ahead.
When he was talking about GT7 and 6, they did get as close as a foot. Now, the astronauts have a little bit of competition between each other. And they had communication up there, but not by radio. They did it by a little sign. I think it was 7 that held up the sign that said, "Go Navy!"
Off to your left, do you remember the red box with the white interior I pointed out over at the rocket garden? Sit it right on the end of that structure lying down. When we brought the Titan IIs out here, they were in the horizontal. We put them right inside that structure and raised them up onto the gray tie-down post that you'll see around the other side. We'd stand the rocket up there, clamp it down. Just before launch, we would lower it. So the picture you see is a multiple exposure of lowering this thing. It didn't drop down and fall onto the ground. And then we would launch from this site like you see that rocket going out of there. Right here on the left is one of the fuel bins. Around the corner and down the road a little, the oxidizer. Unsymmetrical dimethylhydrazine, nitrogen tetroxide. You get them together, they blow. They don't even need to be ignited. Like I said, the government will not put one single dime into an abandoned facility. All we need now is the red tape to be cut. When we do restoration, it will be done to Smithsonian standards. We also need to know who gets jurisdiction to maintain the facility after this is done. We don't think it's right to leave these things fall into the ground and be gone forever. Look underneath of those gray tie-downs. Remember the 18-inch flame deflector? Well, now we have 18-foot flame bucket. And they get a lot bigger. The type of fuel that we were burning, anything that wasn't burned would lay on top of the water that we would spray over that flame bucket, and it would come down through this concrete channel that you see right in front of us. It would go underneath the road, and off to your right there would be a catch basin. We would scrape all that toxic stuff off the top of the water before we allowed it to percolate into the ground. We aren't told. If we hadn't done that in the early days, there still wouldn't be any shrubbery out here, and that's 40 years ago. Off to your right is the catch basin. Somebody told me, yeah, boy, you got all the water you want. There's an ocean right out there. I'm sorry, we do not use salt water. We used fresh water. If you use salt water on this kind of steel, what you see right now, you wouldn't see right now. It would have been gone a long time ago. All of the weed whacking that you see done right here is done by volunteers. They bring their own machines out here and chop it down. If they hadn't have done that, you wouldn't be able to see what you're seeing right now. The brush would be too high. The concrete work that's running from the launch pad back to the blockhouse is a cable tray. It's armored. If the rocket blew up, the signals we get would be the last response, so we need to get that information. It's all hardwired. Back in those days, telemetry was very rudimentary. Just communications with the capsule. You didn't have any of this high-speed technology that would tell us what the conditions of things are within fractions of a second. What do we use this blockhouse for right now? Well, this is where we store all the records from current launches, all the shuttle launches. Once the data has been analyzed, pack it all up, magnetic records, paper records, put them into the blockhouse. What's going to get at them in there? Nothing. If we have a storm coming off the beach that's strong enough to ruin the blockhouse, the rest of it that causes the loss of human life. They'll all tell you the same thing. Fix the problem. Go on with the project. And we did. 1,300 changes were made. People, materials, sources, quality issues, procedures, policies, schedule, everything changed. Slightly less than 2 years, we launched Apollo 7 from this same site. Now we've taken everything out of here except this pedestal. This pedestal was ascribed by Congress to remain. But I have a picture here. When we get out, I'll show you what it looked like back in those days. Right here on Complex 34, 27th of January, 1967. The 27th of January this year, they had a memorial service out here. Mrs. Grissom and others were here. We didn't bring the buses up here. We stayed down there in the parking lot and let these people have their day. This is the price of what we do. If you rush, you're going to make mistakes. If you underfund it, you're going to make mistakes. But we do move on. So we're working on the International Space Station now. We've gone through the Shuttle Challenger problem, pretty much centered around the same reasons. So we're going to be getting out here for a few minutes. I would This blockhouse has walls 41 feet thick. It'll hold 580 people. 2 levels. Periscopes out the top. This even had escape tunnels out the bottom just in case there was a problem and debris all over the place. We still would have to get our blockhouse people out. They would come out through the tunnels, and the tunnels would exit over here on your left. You'll see a couple of poppers right there. Now as we come up here, a little more modern technology up on top of this dome. This is a phase array radar that's capable of tracking anything that we launch till it's out of sight over the horizon. Doesn't matter if there's clouds, hail, sleet, rain, snow, whatever happens up at those altitudes, it doesn't matter. The radar can see right through them. It's not true, of course, with optics. That has to be line of sight. We also have a lot of tracking cameras too. Very, very high resolution. You can see these things until they're almost over the horizon. The last launch that we had with the shuttle, we could actually see the shuttle out 600 miles.
Yeah, there's no restrictions up here. Thank you, sir. 39A.
Okay. How are we doing? 8th of July, 1969. So we did meet John Kennedy's commitment, even with the disasters in the middle. The commitment to, during that decade, put a man on the moon. 4 days later, Neil Armstrong did put that boot mark on the moon. If we had a Saturn V rocket sitting on that launch pad right now, it would be 16 feet taller than the lightning arrestor sticking out the top. The shuttles are nowhere near that tall. You notice the water tank off to the 1,000 gallons of water over that launch pad in 20 seconds. That's to knock down the sound. You remember the flame buckets that we've been pointing to? Over here, it's 65 feet wide, 42 feet deep, 450 feet long, a big flame trench. That flame trench Actually gets rid of a lot of the concussion and feedback that might push the vehicle off course. The concrete part that you're looking at is 65 feet higher than where we are right now before you ever start the steel. Notice the big white tank off to your right. 900,000 gallons of liquid hydrogen. We have one just like it. It's 900,000 gallons of liquid oxygen. 10 hours before launch, we start fueling that orange tank. 523,000 gallons of that fuel. The solid rocket boosters are already fueled when they come out here. At the time of launch, we're burning fuel at 21,270 pounds per second. We're lifting 4.4 million pounds straight up. 8.5 minutes later, we're going 17,500 miles an hour. All these mailboxes you see in the foreground are really cameras. There are 6 posts like that roundabout, all of them mapping what's going on during that very early few seconds of our launch. If you look carefully, about 2/3 of the way up the gantry, you'll see some wires sloping down to the left. At the top of the 195-foot level, there are baskets. The astronauts have a problem after the closeout crew has left. They'll get out of the shuttle, come around to those baskets, climb in, hit release, and they'll ride down that wire. The wire's about 1/3 of a mile long. When they get to the bottom, they'll be doing almost 60 miles an hour. A net will stop the basket. They hop out of the basket, climb into an armored vehicle, and leave the scene. The armored vehicle's there with the door open and the motor running. The first one down that climbs into the vehicle is the driver, no matter who it is. So they're all taught how to drive these special vehicles. We launched all of our moon missions from that pad except one. One of them came from B, which is straight across to your right if you look out that way. A is 18,000 feet from the vehicle assembly building. B is 22,000. That's as close as anybody gets to our launches. So we're going to be going up here to the gantry observation tower. This will be the normal.
You can only see stuff off. You have to pick 2 quarters. Just one. Stack 2 quarters up.
I can remember it kind of Grammy.
That's for the shower. That's cool. Oops, I'm sorry.
That's all right.
Go ahead.
Mr. Talkspace, we have a 4-minute video on the TV monitors overhead. Now this video tells you how things got here. What it doesn't tell you is that there's a 4-story garage door out to the left. It talks about ships and planes and barges and everything else, but it doesn't tell you that the truck comes in through the 4-story garage door on the left. In fact, our truck is sitting right here as we speak. The truck is that, looks like the back end of the shuttle over there. It even has a little tail. So I'll put on the video now, and on the TV monitors overhead, and then just please walk right in, folks, because there's lots of room here, and lots of opportunity to see. And as soon as, and I'll be standing out here, or when the thing is
processing facility, where every piece of the International Space Station launched by the United States will undergo final preparations for the journey into Earth orbit. Like Columbus preparing to set sail for a new world, we now stand on the brink of a bold new era of exploration. Once inside the facility, each element is transported aboard an air-bearing pallet, a moving cushion of air that protects the delicate cargo.